Okay, here is a quick review of all I've done over the past 2 weeks. So mainly to set up two labs, right? The first one is the anti-DDoS SDK feature, where you basically insert the watermark into the packet that is sent from the game server. So later I'm going to show you a demo, basically walk through how it works. Right, and the other one is the captcha, right? So basically, this just to block the bots. Help to enhance the bot protection of the game server. So later, I'm going to show you quickly of these two demos. And over here, right, so I'm going to quickly show you how the anti-DDoS solutions works in common scenarios, and later is some of the innovative solution using the watermark features. So basically, anti-DDoS detection engine. So over here, they see that it's on the edge, for example, the Cloudflare, the Akamai Edge, right, where you ingest all those like traffic data from, for example, the a game user or like the game client. So where they basically identify the packet from OSI layer 4 to layer 7, so that you know that what's basically included in the TCP/UDP header, right? At the pattern of it, how the cadence of sending the packet, receive the packet, some of the malicious patterns, right? So that you can dynamically detect them and get them blocked. And nowadays, some of the innovative features, some of them leveraging like logistic regression or AI machine learning modeling, right? So that it can have like higher efficacy and lower like false positive, false negative rate. And of course, some of the solution provider, they come up with some of the very native solutions like fingerprinting, static fingerprinting feature like AWS, right? So they have the static fingerprinting feature, but it's quite vulnerable to those like packet replay attack, which means that the attacker, they try to basically dig deeper into the packet structure. So they find out actually there's a static fingerprinting, right? So that I can just replicate a packet header so that I can basically conduct a sort of like replay or simulated replay attack, right? To send a packet with the packet structure similar to the what legitimate user is sending, right? So that the AWS, the anti-DDoS edge will know, will be able to block them, right? So this is the advantage or the disadvantage of using the static fingerprinting feature. Of course, on top of that, we need to make sure it's dynamic, right? Of course, I mean, you need the algorithm, right, to be identical from the client side to server side, and also you have to make sure the key, right, they have to match, right? So later, going to show you the details of it. And apart from that, when you select the anti-DDoS solutions or from the game provider or game operator's perspectives, they have to make sure that the anti-DDoS solution provider, they have to make sure they have the number of the nodes that is covering as much as possible around the world, right? Because you want the DDoS traffic to be scrubbed, right? Not nearest to the origin server, but furthest away from the origin server. So you have to make sure that the coverage is as much as possible from the anti-DDoS solution provider. And from the game operator's perspective, I have to make sure that the policies and analytics and statistics is being constantly reviewed so that I can adjust the modeling, adjust the threshold, adjust for example, the policies, rules, and etc. on the timely basis. So basically, this is how the anti-DDoS solutions work. And some of the innovative approaches, I embed the watermark generation SDK into the game client. So whenever the game client is sending out the packet will be structured with the watermark. And over here, the offset byte is where you tell the detection engine on the back end, on the cloud edge, where to find the watermark, right? Because you have different size of watermark. You have a smaller size of watermark, a bigger size of watermark. And over here, is all structured in between the UDP header and the payload. However, for the detection engine, in different countries probably have a different type of setup, but you have to tell the detection engine where to find the watermark from the UDP packet. Right over here, the reason I use UDP packet is you know that the UDP, in terms of performance wise, is better than TCP, right? So that in the FPS game, so you don't like resend the packet, instead you just drop the packet if there's a, for example, the jitter, right, the packet loss, etc. Um, So basically, this is how a SDK, a watermark solution, that's been embedded into a traditional anti-DDoS solutions. However, from the detection engine perspective, I have to make sure two things basically are identical to what's been included in the SDK, right? So the first one is the algorithm, right? So how the watermark is generated, you have to make sure that you understand each other. The first one is the algorithm, right? And the second one is the key, right? Because the solution are not just like customized for one single client. Right? I'm a game operator. There's another game operator from different game client, right? So different client, they might have some of different keys to be used, right? So that from the detection engine's perspective, they can make sure that it's supporting the multi-tenancy, right? So over here, here's the questions that okay, how it looks, right? How I make sure that the key has been constantly changing so that eventually it's not a sort of a static solution. It can be easily hacked, right? Easily replaced. Right, so first of all, I'm going to quickly show you that how a package structure look like. So over here, as I mentioned earlier, first of all, is the algorithm, right? So the solution that we basically demonstrate on is for example using this GameSec DLL, right? This is a library file. So from the code base, yeah. So let me just quickly show you. From the code-based perspective, right? So the DLL is something that will not disclosed by the solution provider. That how I like structure the algorithm, how I construct, for example, the code logic, right? So it will not be disclosed. So you just need to load the DLL that's provided by each of the provider. However, the other part is the key, right? So, for example, different game operator or different game client, a game customer, right? So they each of them will be having a different key, right? So that from the detection engine perspective, so that you can basically identify each of them and basically getting them like separated, right? So basically, this is how a package structure looks like after being printed. Right, so over here is just a very quick demonstration showing you that after I compile the file and I basically quickly run this function, right? That you see that over here, most of them actually they see is identical apart from the this 4 byte, right? This 4 byte of it actually keeps changing, right? But how it changes actually is done according to the algorithm being set from this file, right? So that, first of all, the watermark being generated is dynamic. Why? Because that over here they see that 1 2 3 4 5 6 7 8, right? So basically you can just treat it as, for example, the time step, right? So the more the packet you generated, over here will be added up, right? So over here it's just like 4 byte, the kind of input, right? So that eventually the sequence number will be increasing over the time, right? So that basically this 4 byte this 4 byte and the sequence number over here will keep adding up, keep changing. So that makes sure that the watermark you'll be generating is always dynamic. However, on the detection engines over here, right? Since detection engine also recognize the algorithm that is done that is being built inside this DL file, so that it knows that at what time, what kind of watermark should be accepted. Right. So basically, this is how they recognize each other. And apart from that, is the key, right? So in terms of the key delivery, right, whether it should be static, right? Of course, it's better than like static fingerprinting. But if the key is like, keep it static as for example, for a month, for a year, there's still some of the risks that it can be like leaked, right? So that the ideal way is we always make it dynamic, right? So basically, we do the key rotations over here, right, constantly changing it, and we deliver the key to each of the clients whenever, for example, the game server is being like started or being like under the maintenance window, right? So basically, this is sort of an alternative way to deliver the key dynamically. But I think usually you change it like on a timely basis, because as a game operator, I myself may, for example, update my game client on a timely basis. Okay, I can manually change that, right? So basically, this is in a way that we can make sure the key keeps rotating. And apart from that is, I mean, not all the traffic need watermark, right? So you have to, on the back end, right? So on the DDoS detection engine on the back end, you have to let the back end know that at on what port, right? For example, TCP UDP port like 444, 448, right? And I will need a watermark to be actioning, right? So the rest that I don't need to like do one round of the check of the watermark, right? So that I can offload a bit, right? So basically, this is how sort of integrated SDK watermark-based kind of anti-DDoS solutions work, right? From the client side to the detection engine or the server side, right? And over here is just some of the thoughts that whether, for example, the anti-DDoS should be always on, right? Of course, always on is good, but in terms of the costing internally to the, for example, solution provider, and also in terms of the performance-wise, right, should you put more computing power to the anti-DDoS server? This is a question, right? So whether it should be always on, or I mean, the one that I already touched base on is whether I should rotate the key, right, dynamically or statically or manually, right? So this is some of the topic I've covered earlier, right? So basically, this is how a automatic SDK works. Um, and apart from that, it's a very simple demo showing you that I mean, basically, this is, for example, the game server page. I mean, it's very simplified. It's just showing you that the captcha is available. But the first demo I'm going to build is just the browser base. Probably the next one I'm going to build is on the Android client, right? So over here, I see that when I refresh the page, I have to click it, capture successfully. However, if I'm in the bot, right, so probably I will be like constantly refreshing the page. I'm just simulating myself as a bot. And then, I mean, the slider puzzle will be popping up, right? So on the back end, I think is here. Yeah, you will be able to view that for example, what happened lastly, right? So two requests being blocked is zero because I'm a legitimate user, etc. Right? So basically, this is a very quick demonstration of showing you two approaches blocking, for example, DDoS attack and also the bot attack. Right? So hope it's helpful. Thank you very much.